Hey guys, welcome back to my channel. Today we're going to do questions on indices. These questions are taken from IGCSE Edexcel Maths Say past papers, but you can also use this video to learn how to solve questions for GCSE Edexcel Maths, Cambridge Maths, and O-Level Maths. In this video, we'll be dealing with the easier questions, like somewhere between easy to medium. And then I'll be posting another video which will have the harder questions for IGCSE Edexcel Maths A. Those questions are going to be the highest scoring ones, like marks 5 and 6. These ones are like around 1 to 4, like maximum 4 marks, but majority of them are going to be for like 2 to 3 marks. So let's start with the first question. It says simplify fully 32a to the power of 15 to the power of 3 over 5. So for this, you need to remember the rule of indices, that whenever there's a power outside the bracket and inside the bracket, we multiply the powers. And if there's something being multiplied to the variable, we distribute the power that's outside the bracket on the coefficient as well. So what I mean by that is that when we expand this bracket, like with the powers, it'll be 32 to the power of 305 times a to the power of 15 and then whole power 305. As you can see, the 305 power is distributed on the number and the variable, not just the variable. Now, next thing you need to do is you need to rewrite 32 as a prime number. So 32 is basically 2 to the power of 5. So you can just rewrite 32 as 2 to the power of 5 whole power 3 over 5. And over here, like I said, if there's power outside the bracket and inside the bracket, you multiply the powers. So we can multiply 15 with 3 over 5. Same thing over here, 5 times 3 over 5 as well, because it's power outside the bracket and inside the bracket. So now, 5 times 3 over 5 is 3, so 2 cube. And over here, 15 times 3 over 5 is basically 9, so 8 to the power of 9. So that's 8 times a to the power of 9, because 2 cube is 8. Because 2 cube is 8, so that's your answer. So this was one of the rules of indices. Then in part B, it says express 1 over 10x whole power negative 3 in the form p times x to the power of n, where p and n are integers. So in this case now, there's a negative power outside the bracket. So whenever there's a negative power, like on just a single number, or if there's a fraction, what you can do is you can make the power positive by flipping the fraction. So when I say flipping the fraction, what I mean is that we swap the numerator with the denominator and vice versa. So 1 over 10x becomes 10x, and the power outside will become positive 3 now. So 10 cube times x cube, same thing as we did in the previous question. The power gets distributed on the number and the variable. 10 cube is 1000, so 1000 x cube. So that means p is 1000 and n is 3. That's your answer. Now, in the next one, it says write on the value of m plus 2 whole power 0, where m is a positive integer. So this is another rule of indices, which says that whenever anything is raised to the power of 0, the entire thing has a value of 1. So if it was, for example, 2 to the power of 0, then 2 to the power of 0 would equal to 1. And if it's an entire bracket raised to the power of 0, then the entire bracket has a value of 1. Then simplify 3a squared b to the power of 4 whole cube. This is similar to the previous question. There's a power outside the bracket, and there are powers inside the bracket, and then there's a number inside the bracket as well. So the 3 power that's outside, that is going to get distributed on all of the terms inside the bracket. So 3 cube times a square and then times 3. Like we said, if the powers are outside and inside the bracket, we multiply them. And then b to the power of 4 times 3. 3 cube is 27. A to the power of 2 times 3 is a to the power of 6. B to the power of 4 times 3 is b to the power of 12. That's your answer. So again, a similar question, but now there are more terms, so it's like slightly more difficult, but like the main concept is still the same. First, you need to make the power positive. That's outside. So to make that power positive, we will flip the fraction. So it's going to be 10a to the power of 7 c squared over 2a cubed. And the entire power is now positive 3. Now we distribute the power. So it's going to be 10 cubed times a to the power of 7 times 3 times c to the power of 2 times 3 divided by 2 cubed times a to the power of 3 times 3. Now we simplify this. 10 cubed is 1000. A to the power of 21 times c to the power of 6 over 8 times a to the power of 9. Now we need to further simplify this fraction because we know 1008 can be, divided. And we have an a in the numerator and the denominator. So their powers can also be simplified. Now, how can those powers be simplified? Whenever you have similar variables, like, in this case, a, they're being divided and they have powers. What happens is that the powers get subtracted. So the base remains the same, which is a, but what changes is the power. So what's going to happen now is, firstly, 1000 divided by 8, that's going to be 125. Now, a to the power of 21 divided by a to the power of 9 is going to be a to the power of 21 minus 9. And over here, it's going to be c to the power of 6. So 21 minus 9 is 12. So 125 times a to the power of 12, c to the power of 6. Like I said, when similar bases are being divided, we subtract the powers. So I subtracted the powers. And that gave a the power of 12. So that is another rule of indices. When you have similar bases being divided, you subtract the powers. If similar bases are being multiplied, you will add the powers. Now in this one, it says that we have root of 3 to the power of 5 on one side. And on the other side of the equal to sign, we have k times root 3, where k is an integer. We have to find the value of k. So for this, what we can do is first we can make k the subject. So k would equal to root 3 whole power 5 divided by root 3. Now this root 3 has a power of 1, this root 3 has a power of 5. So when we subtract the powers, because the base is the same, it's 5 minus 1, which is root 3 whole power 4. Now we can further simplify this because the root represents a power of 1 over 2. If it's a cube root, that represents a power of 1 over 3. If it's the fourth root, that's 1 over 4. And if it's the nth root, basically n can be any number, it's going to be 1 over n. That's going to be the power. So over here, it's just a square root with nothing written next to it. So that means it's 1 over 2. So 3 to the power of 1 over 2 whole power 4. And as we said previously, if there's a power outside the bracket or inside the bracket, we multiply the powers. So 1 over 2 times 4, and that's 3 squared, which is 9. So your value of k is 9. Now in this one, we're discussing 3 different rules. Whenever we have similar bases being multiplied, whenever we have similar bases being divided, and when there's a power outside the bracket and inside the bracket. So a good revision question. So the first one, it's x to the power of 5 times x to the power of 7 equals to x to the power of m. We have to find the value of m. So like I said, if two similar bases are being multiplied, we add the powers. So x to the power of 5 plus 7 equals to x to the power of m. 5 plus 7 is 12. So that means m is going to be 12. Then in the second part, similar bases are being divided, which means we will subtract the powers. So y to the power of 8 minus 3 equals to y to the power of n, which is y to the power of 5 equals to y to the power of n. So n is 5. Then simplify fully, 5a to the power of 4 r square whole cube. So like we did previously, if there's power outside the bracket and inside the bracket, we multiply. The power gets distributed on the number as well, not just the variable. So 5 cube times a to the power of 4 times 3 times r square times 3. That's 125 times a to the power of 12 times r to the power of 6. That is your final answer. Then if we look at the next question, this one is slightly different from the ones that we've done previously. We have root 2 divided by 8 cube divided by 16 to the power of 3 over 2 equals to 2 to the power of n. They want us to work out the value of n and show your working clearly. So in this, what you need to remember is that whenever we have different numbers with like powers being, divided, multiplied, or added, whatever is happening, you need to convert all of those numbers in the same base. And it is possible. They will not give you a number that cannot be converted in the same base. They will always give you a number that can be converted in the same base. So over here, we can see that the prime number is 2. So which means we can convert 8 to the base of 2 because 8 comes in the 2 times table. And we can convert 16 to the base of 2 as well because 16 is also in the 2 times table. So what you need to remember is that you need to remember the basic, numbers that come in like the times table and how you can convert them into like similar bases based on what the smallest base is given the question. Like they would give you a question where the smallest base would be 3, and then they would give you like 9, 27, or 81 in that question like this. Or, they would give you something for 5 or like a 10. Those are like the common bases that come, or even like sometimes 7 as well. So you have to keep in mind that the bases are always going to be prime numbers. They're never going to be non-prime numbers. So 8 can be rewritten as 2 cube and 16 can be rewritten as 2 to the power of 4. So we can also rewrite root 2 as 2 to the power of 1 over 2. As I told you previously that root represents the power of 1 over 2. And then we can rewrite 8 cube as 2 cube and 16 as 2 to the power of 4. Now, if you notice, we have the exact same base for all of the terms, which means we can easily simplify this equation and figure out the value of n. So 2 to the power of 1 over 2 divided by, whenever there's a power inside the bracket and outside the bracket, we multiply them. So this becomes 9 and this becomes a 6. Because 4 times 3 over 2 is 6. Now, similar bases are being divided. We subtract the powers. So 9 minus 6 over here. That's 2 cube. Then again, similar bases are being divided. We subtract the powers. So that's going to be negative 5 over 2. Another thing you need to remember is that whenever you have the same base existing alone on both sides of the equal to sign, the powers can be put equal to each other. It can be a variable base, it can be a number base, as long as it's the same and existing alone on both sides of the equal to sign, you can easily put them equal to each other. So n would be equal to negative 5 over 2. That is how you solve this. This is also similar to the question that we did in the previous part. It says that root 2 times 16 equals to 2 to the power of 6. Find the value of x. So same as we did, rewrite 16 as a base of 2. 16 is 2 to the power of 4. So root 2 times 2 to the power of 4 equals to 2 to the power of x. Similar bases are being multiplied. We add the powers. So root is 1 over 2. So 1 over 2 plus 4. That's going to be 9 over 2. And x is 9 over 2. That's your answer. Then 11 to the power of negative 6 whole power 5 divided by 11 to the power 4 equals to 11 to the power of n. Find the value of n. Show you're working clearly. Same thing. First, multiply the powers because it's power outside the bracket and inside the bracket. So that's negative 6 times 5 over 11 to the power 4 equals to 11 to the power of n. Then that's 11 to the power of negative 30 over 11 to the power of 4. And now whenever similar bases are being divided, we subtract the powers. So negative 30 minus 4 equals to 11 to the power of n. That's negative 34. So n equals to negative 34. That's your answer. In this one, it says, given that 3 to the power of 2n plus 3 divided by 3 to the power 4 equals to 3 cubed times 3 to the power of 1 minus 2n. Find the value of n. Show you're working clearly. So once again, similar bases being divided on the left-hand side, so we subtract the powers. So 3 to the power of 2n plus 3 minus 4. And on the right-hand side, similar bases are being multiplied, so we add the powers. So 3 to the power of 3 plus 1 minus 2n. That's 3 to the power of 2n minus 1. And over here, 3 to the power of 4 minus 2n. Same basis on both sides, so put the powers equal to each other. 2n minus 1 equals to 4 minus 2n. 2n plus 2n equals to 4 plus 1. 4n equals to 5, n equals to 5 over 4. That is your answer. Then in this one, it says that given that n to the power of negative 4 over 5 equals to 1 over 2 to the power of 4, where n is greater than 0, we have to find the value of n. So we have to basically isolate just n on one side. Right now, it's n to the power of negative 4 over 5, which means we need to get rid of the power of negative 4 over 5. So what we will do is, we will first rewrite this as n to the power of 4 whole power negative 1 over 5. So to get rid of this negative 1 over 5, what we need to do is we need to multiply both sides with the power of negative 5. Negative 5, negative 5. So that's going to be n to the power of 4. Negative 5 times negative 1 over 5 becomes a 1. And this becomes 1 over 2 whole power negative 20. Now we need to get rid of this 4. So that means we'll multiply both powers by 1 over 4. So that's n equals to 1 over 2 to the power of negative 20 over 4, which is 1 over 2 to the power of negative 5. As we said previously, to make a power positive, we flip the fraction. So it's going to be n equals to 2 to the power of 5, and 2 to the power of 5 is 32. So n is 32, and as you can see, it's also greater than 0. It's not less than 0. Then over here it says simplify 8 squared times cube root of 4 to the power of 6. Give your answer in the form of 2 to the power of a, where a is an integer. Show each stage of your working clearly. So in this question, they've even identified that your answer needs to be in the form of 2 to the power of something. So automatically your mind should go to that thing that, okay, so I need to convert 8 into a base of 2. I need to convert 4 into a base of 2. And like we discussed previously, 8 is 2 cube and 4 is 2 square. So first just rewrite 8 as 2 cube and then whole power 2. Then times the cube root of 4 is 2 square whole power 6. Power outside the bracket, inside the bracket, we multiply them. So 2 to the power of 6 times. Now cube root of 2 to the power of 12. Like I said before, cube root represents a power of 1 over 3. So we can just rewrite that as 2 to the power of 12 whole power 1 over 3, which is 2 to the power of 4. So now when similar bases are being multiplied, we add the powers. So that's 2 to the power of 10. So A over here is 10, and as you can see, the answer is in the form of the base of 2. Another one that is very similar to the one that we did previously, and this one is now 4-mark question. So given that 4 to the power of k plus 3 equals to 16 times 2 to the power of k, find the value of k. Rewrite 4 as 2 square and 16 as 2 to the power of 4. So that's 2 square whole power k plus 3 equals to 2 to the power of 4 times 2 to the power of k. Multiply the powers, so that's 2k plus 6 over here. And over here we add the powers, so that's 4 plus k. Now same bases on both sides, so we put the powers equal to each other. 2k plus 6 equals to 4 plus k. Bring the variables on one side and the constants on the other side. So that's k equals to -2, and that's your value of k. For this one, I would like to do part D because part D is kind of different from what we've seen in most of the questions. So this is a mixture of factorization and indices. So if you notice, we have 2 to the power of n minus 1 in the numerator and 4 to the power of n minus 1 in the denominator. If you remember difference of perfect squares says that a square minus b square equals to a minus b times a plus b. Now, if you notice, 4 is 2 square and 1 is 1 square. If I rewrite the denominator as 2n whole square minus 1 whole square, that's basically a square minus b square. So we can rewrite the denominator as 2n minus 1 times 2n plus 1. And now the 2 to the power of n minus 1 can get cancelled out, and we're left with 1 over 2 to the power of n plus 1. That's how you simplify it. Do not make the mistake of, cancelling out the negative ones and then, simplifying 2 to the power of n over 4 to the power of n by saying it's 1 over, 2 to the power of n, something like that. That's completely incorrect. You cannot simplify terms in a fraction if they're being added or subtracted in the numerator. You cannot simplify them. They have to exist singularly, or the terms have to be multiplied to something for you to simplify it in a fraction. You cannot simplify when it's addition and subtraction. So that's how you solve it. Then this is another question I would like to solve. It says that given that a equals to 3 to the power of x and b equals to 3 to the power of 5, expressed in terms of a or b or a and b. So it says 3 to the power of 2x. So 3 to the power of 2x same as 3 to the power of x whole square. Because like I told you, if the powers are being multiplied, that means like there's a power inside the bracket and outside the bracket. So 3 to the power of x is a, so that's a square. Then we have 3 to the power of x plus 4y. Again, if you recall the rules of indices, powers can be added if similar bases are being multiplied. So if we split this, it's 3 to the power of x times 3 to the power of 4y. 3 to the power of x is a, and for 3 to the power of 4y, we know that b is 3 to the power of y. So if we rewrite this as 3 to the power of y whole power 4, that's a times b to the power of 4. So ab to the power of 4. Then if the powers are being subtracted, that means the bases were divided. So 3 to the power of y divided by 3. So that's b over 3. if you've noticed so far, the questions aren't that complicated. Like they might phrase it like at times weird, but like it's the same type of question being repeated throughout the years. And what you need to remember is your rules of indices. If you practice it enough, you should be able to solve these questions without any difficulty. Now for part B, it says that A is 3 to the power of x and B is 3 to the power of y. A times B is 2187 and A square B is 177,147. Work out the value of x and the value of y. Show your working clearly. So this is a mixture of indices and simultaneous equations, in my opinion. A times B is 2187. So that's 3 to the power of x times 3 to the power of y equals to 2187. Similar bases are being multiplied. We will add the powers. Now we need to check whether 2187 is divisible by 3 and can be written as a power of 3 as well. So 2187 divided by 3. Let's keep on dividing it by 3 until we reach 1. And yes, we can divide it by 3 and write it as a power of 3 as well. So that's 1, 2, 3, 4, 5, 6, 7. It's 3 to the power of 7. So similar bases on both sides of the equal to sign, which means the powers can be put equal to each other. So we can say that x is equal to 7 minus y. That is the first equation. Then if you look at the other one, that's a square b equals to 177,147. A squared is 3x whole square times 3 to the power of y. Simplify it. 3 to the power of 2x plus y equals to 177,147. Again, let's see if we can convert this into a base of 3. So let's keep on dividing it by 3 and see if we reach 1. We do. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 3 to the power of 11 gives us this value. Both the powers equal to each other. This is our second equation. So we can replace x with 7 minus y. So that's 14 minus 2y plus y equals to 11. 14 minus 11 equals to y. That's 3. So y is 3 and x is going to be 7 minus 3, which is 4. So that's how you solve this question. And with that, we're done with the easy and medium level of questions for indices. And for someone who's understood everything, please like and subscribe and share this video with your friends. If there's still any confusions about any of these questions, please leave a comment below and I'll help you out. And stay tuned for the advanced level of indices questions, which I'll be adding to this playlist. And you'll also come across different topics that come in IGCSE Edexcel Maths A. And with the help of those videos, I guarantee you'll be able to understand your topics better than before.